In one way to speak of it, it can be termed as a product rule of integration. Just like our UV formula in our differentiation, we have the same type of formula here for the integral of a product of two functions. In short tips to say, integral of f of x into g of x dx is equal to f of x into integral of g of x dx minus integral of f dash x into integral g of x dx whole dx. This is the famous integration by parts, and in some colleges, some lecturers and some students try to use this, used to use this as integral u dv is equal to, instead of f of x and g of x, they use the letters u and v. Whatever it might be, it is just a matter of symbolism. Instead of f of x and g of x, they use u and v, that's all. This is the pattern. Well, how to remember this, how to use this, that is the matter now. We have to discuss it. Look here, f of x, f dash x, integral g of x. Let a triangle be formed with this. To remember this formula, f of x into integral g of x dx minus integral of f dash x into integral g of x dx. This product minus integral of this product. You can verify. It's easy. F of x into integral g of x minus integral of f dash x into integral g of x dx. Like that. And we feel it easier if we apply this for two or more problems. Let us do one such thing. Suppose x e power x is there. F of x, its derivative, integral of g of x. That is the triangle. What is the answer? X e power x minus this product e power x dx. So it is x e power x minus e power x plus c. That is e power x into x minus 1 plus c. This is a famous answer. That is why I could have taken this problem. Integral of x e power x is e power x into x minus 1, one of the most famous and standard answers. And this will be helpful for us, and it occurs for so many number of times in differential equations also. Yes, it is to be remembered. Integral of x into e power x is e power x into x minus 1 plus c. Well, this triangular diagram helped us a lot in having the answer as quickly as possible. Another rule is also there. Previously, we have used x as f of x and e power x as g of x. If at all you are given the problem like this, then can you take this as f of x and that as g of x? No question of termination like that, it will go on. So, to avoid such type of difficulty, a beautiful rule has been framed. Which function is to be preferred first? Which function is to be preferred next? In the place of f of x, what is to be taken? Like that. Everybody, every student of intermediate or plus 2 standard can easily remember that the rule is IIT. What is that? If at all inverse trigonometric functions are there in the problem, it is to be preferred first. The next preference, logarithmic function. Next preference, algebraic functions. A, that is polynomials. Next tree for trigonometric functions. E, exponential functions. Suppose there is sine 2x into x square. This is the given problem. Do you keep this as it is or do you change? A, T, first preference, algebraic. So x square into sin tx you consider. X square into sin tx you have to consider. Then only it will be easier. Well, next one. There are certain standard answers in this formula, namely integral of x power n into log x dx. It is also a famous answer, x power n plus 1 by n plus 1 into log x minus x power n plus 1 by n plus 1 whole square plus c. How can it be done directly? Let us see. Okay, is it according to the Euler rule or not? No. First preference must be for logarithmic function. Hence, it must be treated as log x into x to the power of n dx. Let us try to use the format of the formula. What is the format? Log x, its derivative, integral of the second, x power n plus 1 by n plus 1. Put a triangle. Come on. Log x into this product, x power n plus 1 by n plus 1 into log x minus integral of this product. You see, 1 by x into x power n plus 1 by n plus 1. What does it mean? There it is x power n plus 1. In the denominator there is x, so that the numerator becomes x power n by n plus 1. What is the integral of x power n? What is the integral of x power n? X power n plus 1 by n plus 1. Hence it is x power n plus 1 by n plus 1 into log x minus x power n by n plus 1 whole square plus c. This is to be remembered. Therefore, I like to write this as a formula. X power n plus 1 by n plus 1 into log x minus x power n plus 1 by n plus 1 whole square plus c. Plus c. It is one of the most standard and useful answers. Let us now think of its reusability. If at all x square log x is asked, what is the answer? In the place of n, what do you have? 2. So that the answer is x cube log x by 3 minus x cube by 9 plus c. If it is x to the power of 4 log x, what is the answer? In the place of n, what do you have? 4. So the answer is x power 5 by 5 into log x minus x power 5 by, it is n plus 1 whole square, that is 25 plus c. Plus c. Well done. I just give you log x, just log x. What is the integral of log x? Of course, we can imagine x power 0 in the beginning. So in the place of n there you have 0. So what happens? X power 0 plus 1 is x log x minus x by 1 square is 1 plus c. Hence it is x into log x minus 1 plus c. Now this is the new formula now, new heroine now, S. What is integral of log x dx? It's just nothing but x log x minus x plus c. Actually, this is to be learnt in the very beginning itself as a formula, but it is possible for us to get it derived like this. Yes, these are all the results of this beautiful formula, integral of x power n into log x. Next one. Observe these problems. In all these problems, a polynomial x square, x cube, x like that, and an exponential function is present. For these problems, or in fact actually speaking for any type of such problems, there is a beautiful condition of applying this rule, product rule, that is f of x, f dash x, f double dash x, f triple dash x, etc., etc. f1. By f1 I mean integral of the second function, g2, second integral, that is integral of g1, g3, g4, etc., etc. The ultimate answer is this product minus this product plus this product minus this product and so on. That is an easy technique. That technique has been observed simply by means of observation only. By the repeated application of this product rule, it can easily be observed. Let us now try to apply this here in this problem. We shall now apply that procedure. This is f, x square, its derivative, its derivative, its derivative. Stop there. Second function, its integral, integral of this, integral of this, integral of this. Imagine the answer, x square e power x minus 2x e power x plus 2 e power x minus 0. That's all the answer. Let us apply the same for that. This problem, what is going to happen? X cube, its derivative, 3x square, its derivative, 6x, its derivative, 6, its derivative. We can stop there because its derivative is 0. Integral of 2 power x by log 2. Integral of this, 2 power x by log 2 whole square. Integral of this, 2 power x by log 2 whole cube. Integral of this, 2 power x by log 2 whole power 4. Stop. Why should you stop there? Because derivative of 6 is 0. It is a waste matter to consider. Come on. Let us design, let us construct the answer. This product minus this product plus this product minus this product. What is that? X cube into 2 power x by log 2 minus 3x square into 2 power x by log 2 whole square plus 6x into 2 power x by log 2 whole cube minus 6 into 2 power x by log 2 whole power 4 plus. Imagine how easier it is to trace the answer, to collect it, to pick out the answer. Without much effort, with a little effort, we are able to have the answer. Just like this, can you tell me the answer for x e power 2x? Why not? It can be done. X e power 2x. X, its derivative is 1. Stop there because derivative of 1 is 0. You can stop there. Integral of e power 2x is e power 2x by 2. And the integral of this one is e power 2x by 4. So, answer is visible before us. You can read with your own eyes. What is the answer? X e power 2x by 2 minus e power 2x by 4 plus c. Yes, that is the easy matter we generally use by applying the chain rule of application of a product rule. Okay, well, next one. Not only for algebraic function and exponential functions, if you have a polynomial of the form x square, x cube power 4, etc. among in the two functions, then this technique is applicable. As an example, you observe this is x cube sin x. First function is x cube, its derivative, its derivative, its derivative, and stop. Sin x, integral of sin x is minus cos x, integral of minus cos x is minus sin x, integral of minus sin x is cos x, integral of cos x is sin x. Come on friend, you can read the answer. What is the answer? Minus x cube cos x plus 3x square sin x minus 6x cos x plus 6 sin x plus c. There ends the matter. There ends the matter. The benefit here we are having is x cube is present. What is the specialty and what is the benefit you are having? Its derivative after some stage it will be annihilated, or it vanishes. X cube, 3x square, 6x, 6, stop. Isn't it? Like that. If at all there are functions of the form e power x into sin x, then it is a tedious job, of course. Derivative of e power x does not vanish, derivative of sin x also does not vanish. Actually, you have to take it as sin x into e power x. Of course, by using complex numbers, it can be done. And we have a list of such problems, formulae. We shall discuss with them later. There has been another beautiful formula before us. We first discuss with that and later on we come to deal with that. Okay. Inverse trigonometric functions. Inverse trigonometric functions. Sin inverse x. How to get it? It's very simple. Even though it is a problem, it is a numerical problem, the answer can be read within one step. Of course, you can treat this as sin inverse x into 1 dx. Come on, use the triangular pattern. Sin inverse x, its derivative, integral of the second. Come on, use it. It is x sin inverse x minus x by root 1 minus x square dx. Okay, here I like to write minus 2x plus 1 by 2. This is x sin inverse x dx plus half into, imagine it my dear, f dash x by root of x. F dash x by root of x is 2 root of x. That is 2 into root 1 minus x square plus. Then it is x sin inverse x plus root 1 minus x square plus c. If it is cos inverse x, we do the same. We do absolutely the same. If it is tan inverse x, yes. Let us do one more such. What is integral of tan inverse x dx? It's nothing but tan inverse x into 1. Use the triangular pattern. Tan inverse x and its derivative, integral of the second. Integral of 1 is x, isn't it? So, what is the answer? X tan inverse x minus x by 1 plus x square dx. What is lacking here? Derivative of 1 plus x square is 2x, isn't it? 2 is missing. You offer it. What is there? F dash x by fx. What is the answer? Log mod fx. Hence the answer is x tan inverse x minus half log mod 1 plus x square plus c. Accordingly, you can be in a position to integrate secant inverse x, cosecant inverse x, cot inverse x, whatever inverse function you have at your disposal, you can answer it. So, the very purpose and very utility of this so-called integration by parts reflects here by integrating indefinitely the inverse trigonometric functions. Yes. Another benefit of, another application of, useful application of by parts, integration by parts formula is integral of e power x into f of x plus f dash x dx is equal to e power x into f of x. The proof is also very simple. Why and how? Look here. This can be taken as integral of e power x into f of x dx plus integral of e power x into f dash x dx. Use the by parts formula here. F of x into integral of e power x minus f dash x into integral of e power x dx plus e power x into f dash x dx. Just within one step we are able to have the answer as e power x into f of x plus c, of course. Even though it looks simple, it has a wide range of applications. So, how many applications are there for this formula? And let us observe some of those applications. Integral of e power x into sin x plus cos x. One can easily read out the answer. This is f of x and that is f dash x. So the answer is e power x into sin x plus c. Integral of log x plus 1 by x. Come on. Log x plus 1 by x. This is f of x and this is f dash x. It's very simple. It is looking like that. So the answer is e power x into f of x, that is e power x into log x. Another cunning problem is there before us. Try to get it answered. E power x into log x plus 1 by x square. It is 1 by x square, but not 1 by x. Even if this log x is supposed to be some f of x, it is not f dash x, something extra. How to get it done? A simple thought, a simple idea can change the life of this problem, of course, as how to get it answered. It's very simple. Look here. This is e power x into log x minus 1 by x plus 1 by x plus 1 by x square. I think you could have observed what I have done. I have added and subtracted minus 1 by x plus 1 by x. Well, what miracles are going to be happen now? What is the benefit you are going to get? You consider this entire thing as f of x. What is the derivative of log x? 1 by x. What is the derivative of minus 1 by x? 1 by x square. Therefore, this is made as f dash x, isn't it? Again, this could arrive the shape of e power x into f of x plus f dash x. Hence, the answer is e power x into f of x, that is e power x into log x minus 1 by x plus c. Plus c. Yes. There are still some more applications for this. Let us try it. Let us use them. Consider the problem e power x into x plus 1 by x plus 2 whole square. This can be taken as e power x into x plus 2 minus 1 by x plus 2 whole square. You can split this quantity inside the bracket into two parts. What are those parts? E power x into x plus 2 by x plus 2 whole square minus 1 by x plus 2 whole square dx. Automatically x plus 2 by x plus 2 whole square is 1 by x plus 2. Exactly its derivative is present here, that is minus 1 by x plus 2 whole square. Hence the answer is e power x by x plus 2. Consider the problem. E power x into x plus 2 whole square by x plus 4 whole square. Well, my dear friend, you think of the problem and you suggest me an idea. Here also, one simple idea can change the life of this problem. You think of. Let us simplify this as e power x into x square plus 4x plus 4 by x plus 4 whole square. I think you could have understood what I could have done. I have just expanded x plus 2 whole square. This is equal to e power x into x plus 4 by x plus 4 whole square plus 4 by x plus 4 whole square dx. You can cancel x plus 4 here so that it is e power x into x by x plus 4 plus 4 by x plus 4 whole square. The crucial and important thing here which is to be observed is find the derivative of x by x plus 4. It is just nothing but 4 by x plus 4 whole square. Yes, you please recollect the formula from derivatives. D by dx of ax plus b by cx plus d. What is it? It is ad minus bc by cx plus d whole square. I think you could have recollected this. Here x by x plus 4 is also in that form, that is d by dx of x by x plus 4 I am writing 1x plus 0 by 1x plus 4, absolutely in the similar fashion. Come on, d minus bc, 4 minus 0 is 4 by x plus 4 whole square. You can easily trace it. Come on, this is f of x and this is f dash x. So ultimately what is the answer? This is just nothing but x e power x by x plus 4. Like this. At times we may have to use according to the consequence, according to the context and according to the needfulness. So that the answer for this question is x e power x by x plus 4 plus c. We're taking this as f of x and that as f dash x. Another important and beautiful application of integration by parts is e power x into sin bx plus c dx and e power x into cos bx plus c dx. In a brief form, they can be given like this. E power x by r into sin of bx plus c minus theta and e power x into cos bx plus c dx is equal to e power x by r into cos of bx plus c minus theta. Here two new things are appearing. One is r and another is theta. From where we could have obtained them? It's very simple. A is equal to r cos theta, b is equal to r sin theta, r is equal to root of a square plus b square, and theta is equal to tan inverse b by a. Therefore, without using the symbol, the full form of the answer is e power x by root of a square plus b square into sin of bx plus c minus tan inverse b by a. Here it is e power x into cos bx plus c dx is equal to e power x by r into cos of bx plus c minus r is nothing but root of a square plus b square. Cos of bx plus c minus theta means tan inverse b by a. The proof of this theorem, proof of this formula can be obtained in two ways. One is by using integration by parts successively, and another is using complex numbers. As and when you look at cos theta, it is nothing but the real part of e power I theta, isn't it? No. Imagine the set of complex numbers. What is e power I theta? Is equal to cos theta plus I sin theta, isn't it? Okay, e power I theta is equal to cos theta plus I sin theta. What is cos theta? A real part of e power I theta. What is sin theta? Imaginary part of e power I theta. Okay, if you take sin bx plus c as imaginary part of e power bx plus c, I into e power bx plus c, this is e power ax plus I into bx plus c. It can be integrated as usual. The answer can easily be obtained as e power x by r into sine of bx plus c minus theta by comparing the imaginary parts of the integrals. That is the second way. So in almost all these problems, as and when we come across such functions, we use complex numbers. How can it be done? Let us view some such examples. By the by, let us have a good practice of this formulae using 2 or more examples. Look here. Integral of e power 2x into sine 3x. What is the answer? E power 2x by r, root of a square plus b square is root 13 into sine of 3x plus bx plus c minus theta. What is theta? Tan inverse b by, that is tan inverse 3 by 2 plus. Likewise, you can have the answer for e power 4x into cos 6x like that. For such problems, you will be ready to have the answers using these. Well, let us observe the solution of this problem. X, e power x, sin x, 3 functions are there. To use integration by parts formula, it is somehow a lengthy process. Then what to do? We use like this. X into e power x into imaginary part of e power ix. I think you could have observed. In the place of sin x, I have written imaginary part of e power ix. So that it is imaginary part of integral of x into e power x plus ix. That is 1 plus I into x dx. Okay, this is equal to imaginary part of now x into e power ix, e power 1 plus I into x by parts formula, the triangular format. What is that? x1, integral of this is e power 1 plus I into x by 1 plus I. Okay, imaginary part of, come on tell me, x into e power 1 plus I x by 1 plus I minus integral of this product. What is that? E power 1 plus I into x by 1 plus I dx. This is therefore imaginary part of x into e power x into e power ix by 1 plus I minus e power x into e power ix by 1 plus I whole square. Am I correct? Plus c. In this entire thing, bracket, we are supposed to pull out the integral part only, isn't it? Well, this is imaginary part of this. X into e power x is a 1 plus I is in the denominator. If you multiply with 1 minus I in both numerator and denominator, it becomes 1 plus I into 1 minus I is 1 minus I square, that is 2. 2 into e power ix. What is e power ix? Cos x plus I sin x into 1 minus I minus, what is say about this? This is all imaginary part of. This is all imaginary part of. What do you say about this? This is e power x, x into e power x by 1 plus I. If you multiply both numerator and denominator with 1 minus I, it becomes 2 square, that is 4 into e power ix is nothing but cos x plus I sin x into 1 minus I whole square. Like that you are supposed to proceed. Of course, 1 minus I whole square is 1 plus I square minus 2i. It's just nothing but minus 2i, isn't it? Because 1 plus I square is 0. So that the next step, in the next step or other, you try to pull out the imaginary part that comprises the answer. You see, to use by parts rule successively is more difficult when you compare that with this procedure. So with this procedure, we are supposed to get the answer as and when you have three functions of this form. Somehow in some functions there are some problems, x into e power 2x into cos 3x may be there. For cos 3x, what do you write? Real part of e power 3ix you write. Use the complex number system. And this is a very simple matter, of course. In this procedure, we are supposed to get the answer. Let us see some more applications of the formula integration by parts. Observe these three questions. Integral of root of a square plus x square dx, root of a square minus x square dx, root of x square minus a square dx. Of course, in order to apply product rule, that is by parts formula, into one you may have to take. You take, of course, right. To write the answer or to remember the answers is very, very easy. These three formulae look alike. All of them start with x by 2 into root of a square plus x square, x by 2 into root of a square minus x square, x by 2 into root of x square minus a square, x by 2 into problem, x by 2 into problem, x by 2 into problem. Coefficient of a square is plus, coefficient of a square is plus, coefficient of a square is minus, plus, plus, minus. A square by 2, a square by 2, a square by 2. It's not over. Still something is there to be put. If this root a square plus x square occurs in the denominator, what will be the answer? What I mean to say is integral of 1 by root of a square plus x square. How much? There are two answers. One is log mod x plus root of a square plus x square. Another is sin h inverse x by a. And in most of the cases we use log mod x plus root of a square plus x square. It is also, this is also log mod x plus root of x square minus a square. But in this case, if root of a square minus x square lies at the denominator, what happens? What I mean to say is 1 by root of a square minus x square. What is the answer? Sin inverse x by a. Therefore, it is sin inverse x by a. These three questions and these three answers have so many similarities and very few differences. This is the similarity. X by 2 into problem, like that. And the second part, every second part starts with a square by 2, a square by 2, a square by 2. If the coefficient of a square is negative in the question, in the answer it is also minus a square by 2. If it lies in the denominator, the answer is. If it lies in the denominator, the answer is. If it lies in the denominator, then the answer is. So it is an easy matter, of course, to remember and to use the answers. Well, should you believe them? Or is there any proof? The proof is also very simple, and we shall check one proof. It's very easy, of course. It is very easy. That is why I am tackling with that. Otherwise, it will be beyond the scope of our time of our class. Yes. A root of a square plus x square dx, it is equal to root of a square plus x square into 1. Therefore, the first function is f of x is root of a square plus x square, and second function, that is g of x, is 1. Again, let us use the triangular pattern. What is that? Root of a square plus x square. What is the derivative of root of a square plus x square? Root x 1 by 2 root a square plus x square into derivative of a square plus x square is 2x, so it is x by into x. I think you could have understood the pattern. F of x, f dash x, integral of g of x. Come on, what will be the answer? Product x into root of a square plus x square minus integral of this product x square by root of a square plus x square dx. Well, it is equal to x into root of a square plus x square minus, you can write x square as a square plus x square minus a square by root of a square plus x square dx. You can now split this into two integrals. You see, let me call this LHS as I. A square plus x square by root of a square plus x square. Root of a square plus x square is nothing but the problem, that is I. So minus I, if it comes to this side, it becomes I plus I is equal to x into root of a square plus x square. Well done. The second part, minus of minus plus a square into 1 by root a square plus x square. What is its answer? Log mod x plus root of a square plus x square. Come on, friend. Is it I or 2i? It is 2i. Therefore, as this is 2i, let me write 2c. Divide throughout with 2. What is happening? Y is equal to x by 2 into root of a square plus x square plus a square by 2 into log mod x plus root of a square plus x square plus c. Likewise, you can see the proofs for the remaining two problems also. Yes. In the methods of integration, the next method of integration which is before us is integration of, that is indefinite integration of, rational functions in which the denominator occurs with trigonometric functions. What I mean to say is integral of 1 by 3 plus 4 cos theta. Integral of 1 by 4 sin theta plus cos theta. Integral of 1 by 3 plus sin theta d theta, like that. In general, integral of 1 by a cos theta plus b sin theta, or 1 plus a cos theta, or 3 plus b cos theta, or 5 plus something, comes some constant plus either cos theta or sin theta or both. This is the pattern. This is the standard model. And to solve this model, a beautiful technique, or rather procedure, has been designed. What is that procedure? Cos theta is visible here. Put tan theta by 2 is equal to t. That is a fixed branded substitution. As and when you look at cos theta, sin theta are both in the denominator. That is the fixed and branded substitution. And let us see what is going to happen. What is the derivative of tan theta by 2? For tan theta by 2, it is secant square theta by 2. For theta by 2, it is half. For theta, it is d theta is equal to dt. You see, what is secant square theta by 2? It is 1 plus tan square theta by 2. It is nothing but 1 plus t square. Isn't it? Therefore, d theta is equal to 2 dt by 1 plus t square. Why is it so? This 2 becomes that side 2 dt. This is 1 plus t square in the numerator here. It becomes the denominator there. Therefore, by taking tan theta by 2 is equal to t, the fixed substitution, the fixed transformation is also d theta is equal to 2 dt by 1 plus t square. Well, what is the fate of this problem? It's very simple. I is therefore equal to integral of 1 by 3 plus, what is cos theta? 1 minus tan square theta by 2 by 1 plus tan square theta by 2. You see, the plan of substituting this tan theta by 2 is equal to t is both sin theta and cos theta have beautiful formulas in terms of tan theta by 2. That is the only reason. So, what is cos theta? 1 minus tan square theta by 2 by 1 plus tan square theta by 2. So, it is 1 minus t square by 1 plus t square. 1 minus t square by 1 plus t square. And in the place of d theta, we have 2 d theta by 1 plus t square. Multiply both numerator and denominator by 1 plus t square. What is going to happen? 2 d theta by 3 into 1 plus t square plus 1 minus t square. I'm sorry, 2 dt by. So that it can be obtained to the standard form, of course. This is 3 plus 3 1s are 3, 3 plus 1 4, 2 dt by 4 plus 3t square minus t square is 2t square. You can cancel 1 2 here. This is nothing but dt by 2 plus t square. It looks like 1 by a square plus x square. Hence the answer is 1 by a tan inverse x by a, 1 by root 2 tan inverse t by root 2. But what is t? Of course, what is t? Tan theta by 2. You directly substitute there. Tan inverse of tan theta by 2 by root 2, 1 by root 2 into plus. That becomes the answer. Okay, instead of cos theta, if you have cos 2 theta, then what happens? We take tan theta is equal to t. If sin 2 theta is there, then also we take tan theta is equal to t. Why? Because cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta. And sin 2 theta is equal to 2 tan theta by 1 plus tan square theta. So for both cos 2 theta and sin 2 theta, we have formulas connecting tan theta. That is the benefit we are having in substituting tan theta by 2 is equal to t or tan theta is equal to t. Okay, suppose we have sin theta instead of cos theta, or both sin theta and cos theta we have 1 by 1 plus sin theta plus cos theta d theta. What is 1 plus cos theta? 2 cos square theta by 2. 2 cos square theta by 2. What is sin theta? 2 sin theta by 2 cos theta by 2 d theta. Multiply both numerator and denominator, divide both numerator and denominator with cos square theta by 2. What happens? Secant square theta by 2 d theta by 2 plus 2 tan theta by 2. Now you can directly take tan theta by 2 is equal to t. Tan theta by 2 is equal to t. Then half secant square theta by 2 d theta is dt, or secant square theta by 2 d theta is 2 dt. Integral of 2 dt by 2 plus 2t, where t is equal to tan theta by 2. Automatically 2 will be cancelled, leaving you 1 by 1 plus t. Its integral is 1 by 1 plus t is log mod 1 plus t, log mod 1 plus tan theta by 2 plus c. In some problems, both sin theta and cos theta along with some other constant might be present. No problem, we use the same style of substitution, that is either tan theta by 2 is equal to t or tan theta is equal to t according to the needfulness, according to the context. We use the substitution. Okay. Now, the integration of algebraic and rational functions that comes to the fray. How many methods are there? How many models are there? Let us see. Where if they are 1 by ax square plus bx plus c, px plus q by ax square plus bx plus c, px plus q by root of ax square plus bx plus c, root of ax square plus bx plus c, second degree expression in the denominator, second degree expression in the denominator with square root symbol, provided with a first degree expression in the numerator. Like that, there are so many. There are so many models. As one by one, let us observe the things, discuss with the method and leave them. Otherwise, it will be a tedious job to go through all those problems. Let us just discuss the models. Now, we take interest in dealing with this model. Integral of 1 by x square minus 3x plus 2. It is a second degree polynomial which is reducible. What I mean to say is it can be factorized. As in when it is factorized, it can be split into partial fractions. What are the partial fractions? 1 by x minus 2 minus 1 by x minus 1. This is nothing but log x minus 2 by x minus 1 plus c. As and when it is possible to split into partial fractions, you can do that. One more problem, 1 by 2x square minus 5x plus 2. Can it be split? Why not? It can be. How? It is 1 by 2x minus 1 into x minus 2. What are the partial fractions regarding the same? By 2x minus 1 by x minus 2. To know this number, what is to be substituted in the place of x? Half. Substitute half minus 2 is minus 3 by 2, isn't it? If it comes to the numerator, it is minus 2 by 3. Well, what will be there above x minus 2? You have to take 2. 2 2s are 4, 4 minus 1 is 3, isn't it? It is 3 dx and integrate. So that it is minus 2 by 3 into log mod 2x minus 1 by 2. 2 gets cancelled, 1 by 3 into etc. plus 3 log x minus 2. It's not impossible. We are intended to know the method only. So in this method, the first pattern is a reducible quadratic. That is that quadratic form which can be split into two factors. If it is reducible, we can split into partial fractions and thereby we integrate it. Well, what happens when it cannot be reduced? 1 by x square plus 2x plus 5. Can you split this? No, it's not reducible. Then what do you think of? You observe the two terms containing x squares and x's. Let us use the perfect squaring technology. What I mean is this x square plus 2x. What constant do you need to have this as a part of a perfect square? 1. What is to be added? Half of the coefficient of x whole square. What is the coefficient of x? 2. Half of it is by 2. Its square is 1. What do you need? We need 1. Okay, this can be taken as x square plus 2x plus 1. 1 by x square plus 2x plus 1 plus 4. The first three things together give you x plus 1 whole square. It is 1 by x plus 1 whole square plus 4 is 2 square. Come on friends, this looks like 1 by x square plus a square, isn't it? Its answer is 1 by a tan inverse x by a. That is 1 by 2 into tan inverse x. In the place of x, we have x plus 1 by a plus. One more thing. Integral of 1 by 2x square plus 3x plus 4 is there. Sure, it cannot be. It is not, it is irreducible as linear factors. What can we do? Similar pattern. You see, the method of perfect squaring becomes easy when and only when the coefficient of x square is 1. Observe that. It is 2. What should be done? You pull that bloody 2 out. 1 by 2 into 1 by x square plus 3x by 2 plus 4. At any cost, I want to observe that as a perfect square. What is the coefficient of x? 3 by 2. Half of it, 3 by 4. Square of it, 9 by 16. So, plus 9 by 16 minus 9 by 16. You just add. What happens? This is equal to half into dx by the first three things give you x plus 3 by 4 whole square. X plus 3 by 4 whole square. Next, what is this? 64 minus 9. What is 64 minus 9? It is 55. Plus or minus? 55 by 16. Again, that looks like x square plus a square. In the place of x, we have x plus 3 by 4. And in the place of a square, we have 55 by 16. And so what is a? Root 55 by 4. Accordingly, you design the answer. What is the answer? 1 by a tan inverse x by a. This is half into 1 by a, 1 by root 55 by 4 into tan inverse of x plus 3 by 4 by root 55 by 4. Of course, by multiplying it with 4, it is 4x plus 3 by root 55. It can be simplified according to the necessity and according to the availability in the given options. You can do that. We are interested to know the methodology only. Therefore, if it is irreducible, it is to be made a perfect square. Well done. This is equal to, now, px plus q by ax square plus bx plus c. This is the next model we are now going to deal with. So what is the specialty here? Numerator contains a first degree expression and the denominator contains a second degree expression. Again, from this, two cases will arise. What are the two cases? Ax square plus bx plus c is reducible. Ax square plus bx plus c is irreducible. Reducible means factors will come to the denominator. The model, an example for this model is 2x minus 3 by x square minus 7x plus 10. What do you do? As usual, partial fractions. This is nothing but x minus 2 into x minus 5, so that it can be split into partial fractions. 2x minus 3 by x minus 2 into x minus 3. And it is an easy matter to read the answer directly in terms of partial fractions. No problem at all. That is an easy model. Well, that case, that is when the denominator is irreducible, that linear factors may not be obtained directly. Let me give you the example. 3x minus 2 by x square plus x plus 5. In that case, what is to be done? Now, we take special interest in dealing with that problem. This is it's a very easy problem because partial fractions involvement is there, so it is not difficult at all. And something is new. What is to be done there? We shall see. We shall look at this. Integral of 3x plus 1 by x square plus x plus 5 dx. What is x square plus x plus 5? Second degree irreducible polynomial. And numerator is of first degree. In this case, the very first step is supposed to be numerator is equal to a constant into derivative of denominator plus another constant. That is, the main purpose in that pattern is you are supposed to change the numerator in such a way that derivative of the denominator occurs there. What benefit you are going to get by changing like that? F dash x by fx is nothing but log mod fx. Like that. Okay. How can you do this? At any cost, we should have 2x plus 1. Why? Derivative of denominator is there. Derivative of denominator is 2x plus 1. But you see, here we have 3x. Here we have 2x. What should you do? 3 by 2. 2 into 2? Go away. 3x. Okay. But here we should have 1 only. But here we had 3 by 2. How to make it 1? It is 3 by 2. It is to be made 1. You may have to subtract half. 3 by 2 minus half is 1 by x square plus x plus 5. What I mean to say is you can easily mention by this simple calculation, or otherwise you follow that step. You follow that step. That is 3x plus 1 is equal to a into 2x plus 1 plus b. By suitable comparison, you will be able to have a and b. Of course. What I mean to say is, for those students who are at JEE advanced level, it is not impossible to have the answers for a and b like this. Okay, this can be split into two parts. One part is this by this, f dash x by fx, log mod fx. So 3 by 2 into log mod x square plus x plus 5. That is the very benefit which we anticipate by changing the numerator like that. And what is the second part? Minus half into integral of 1 by x square plus x plus 5 dx. This is of course, is after the first model, x square plus x plus 5, you are supposed to transform into a perfect square, either in the form x square plus a square or x square minus a square. For both of them we have the formula. Yes, this is the pattern of this model. Next one. We name these models 1 by root f x square plus bx plus c dx and integral of px plus q by root of ax square plus bx plus c as special models, but they are not such. Here in this case, the second degree expression which lies inside the square root, it is immaterial even when it is reducible or irreducible. Even it is reducible, you may not be in a position to use the partial fractions style. Why? Because root of some product of two linear factors cannot help us to split in terms of partial fractions. So every such problem can be again split in the same way. For this, pakka perfect squaring, absolute methodology to use it is perfect squaring. Of course, you may have to pull a out, 1 by root a into 1 by root of x square plus bx by plus c by, like that. There also. Of course, for this there is an additional procedure. What is that? Let px plus q is equal to a into 2ax plus b plus b. I am not speaking of numerator and denominator there. Why? Because if you speak of denominator, the entire root of etc. comes into fray. We don't want that. If you want to express in terms of that language, numerator is equal to a into derivative of second degree expression in the denominator plus b. Is it necessary? No, not necessary. Use that. So that with this pattern, this again be split into two parts, namely a into 2ax plus b by f dash x by root of x formula is to be encashed there. That is 2 root of x plus the other pattern, this model. Like this, we make an attack of solving such problems. We shall now look at some other models which may not be thrown into a particular standard model. They look special. Such problems we shall look at. X square minus 1 by x square plus 1. Look here. This can be taken as x square plus 1 minus 2 by x square plus 1. Again, it can be split into two forms. X square plus 1 by x square plus 1 minus 2 by x square plus 1. Answer can easily be read as x minus 2 tan inverse x plus c. Now you look at the integral of 1 by 1 plus x power 4. Integral of 1 by 1 plus x power 4 dx. How can you take? How can you consider? Can you take x square is equal to t? Not possible. The beautiful style that must be adapted here to answer such questions is 1 by x square by x square plus 1 by x square. One by x square, I am dividing both numerator and denominator with x square. What is going to happen? 1 by x square by x square plus 1 by x square. Come on friend, you tell me the idea. What do you do? Actually speaking, the next immediate step is this is equal to 1 plus 1 by x square minus 1 minus 1 by x square by x square plus 1 by x square. You please observe what could I have done. I have added 1 and subtracted 1. 1 by x square minus of minus 1 by x square is 2 by x square. But you see, there is only 1 by x square. So you cancel that 2 here. Okay, you could have split it into two parts. What is the benefit you are going to get? This is equal to half into integral of 1 plus 1 by x square plus 1 by x square minus half into integral of 1 minus 1 by x square plus 1 by x square dx. Well, two integrals appear before us. Let us now consider both of them individually and separately. What is the fate of I1? What is I1? It can be written as half into 1 plus 1 by x square by x minus 1 by x whole square plus 2. You please observe. You please observe. What is x minus 1 by x whole square? X square plus 1 by x square minus 2. Plus 2 is there. Why should I write like this only? In the next step, I am going to take x minus 1 by x as t. Automatically 1 plus 1 by x square dx becomes dt. Isn't it? So that this is equal to 1 by 2 into dt by t square plus 2. Where? What is t? X minus 1 by x is equal to t. Finished. Yes, finished. How? This looks like 1 by x square plus a square. And in the place of a square we have 2. That is, in the place of a we should have root 2. So this is 1 by 2 root 2 into tan inverse t by root 2 plus c. The first part is done. What about the second part? 1 minus 1 by x square by. How to deal with that? We shall do. This is of course I1. I would like to remove this to save the space to answer the second part, that is I2. What is I2? Half into 1 minus 1 by x square by, observe carefully about the denominator, what I am able to write here, x plus 1 by x whole square minus 2. Here I am going to suppose x plus 1 by x as t, so that 1 minus 1 by x square dx becomes dt. Not only that, x square plus 1 by x square plus 2 minus 2 will go away, leaving you x square plus 1 by x square. Leaving you x square plus 1 by x square. So that it is again half into dt by, here it is t square minus 2. Previously it was t square plus 2, but here it is t square minus 2. Okay, where, what is t? X plus 1 by x. Come on friends, it is in the shape of 1 by x square minus a square, and in the place of a square we have 2, that is in the place of a we have root 2, that is 1 by 2 is here, 1 by 2a is going to come, so that is it is 2 root 2 into 2 is 4 root 2, 1 by 4 root 2 log mod t minus root 2 by t plus root 2 plus. What is t? X plus 1 by x, 1 by 4 root 2 into log mod x plus 1 by x minus root 2 by x plus 1 by x plus root 2. Let me multiply with x, then what happens? X square plus 1 minus x root 2 by x square plus 1 plus x root 2 plus. You join the previous part and this part so that the answer will be obtained. If you have 1 by 1 plus x power 4 like that. So according to the need of the problem, we divide both numerator and denominator with x square. Yes, this is a peculiar model of the problem. Still there are some models which will come across while solving the problems. And another topic before us is reduction formulae. What are reduction formulae? You see, if integral of sine x is required minus cos x, integral of sine square x is required 1 minus cos 2x by 2, we will have x minus sine 2x by 2 we have. If sine cube x, integral of sine cube x dx is required, then sine cube x means 3 sine x minus sine 3x by 4, even that can also be had. If integral of sine power 6x is required, integral of sine power 8x is required, it's not an easy matter, of course. So for such things, we must be having a fixed mold type format. That's nothing but called, that nothing but to be discussed under the heading reduction formulae.